Hello everyone, I am Roy speaking again with the DDCO Lab assignment. Let's see what the second question is. The given question is that design a 4-bit full adder and subtractor and simulate the same using basic gates. As you can see, this is the truth table of the full adder and this is the logic gate circuit of the full adder. The inputs are A, B and carry in and the outputs are carry out and sum. The value of the sum will be equals to 1 when only one or three inputs values is equals to 1, but the carryout will be 1 when only 2 or 3 inputs will be equals to 1. And if we assign A is equal to 1 and B is equal to 0 and C is equal to 1, we will get the sum as 0 and carryout as 1. Let me tell you how exactly it works. This is an exclusive OR gate. This is also an exclusive OR gate. If we assign A is 1, B is 0, this will give the output as uh, uh, this will give the output as 0. Since that carry in is also 1, but the output value here is 0, we will get the output as 0. Now from here A and B values are 1 and 0 and this is an AND gate. We will get the value as 0, and here also we will, since A is 1 and C is 1, we will get the output as 1, but here we will get the output as 0. Since this is an OR gate, we will get the output as 1 here and 0. So the carry out will be equals to 1. These are the k-maps represented here. This is the three variable k-map for the carry out, and this is the three variable k-map for the sum, which is taken from the truth table of the full adder. This is the expression for the sum output, and this is the simplified expression of sum, and this is the output of the carry out. We shall discuss briefly in the later upcoming video. Now we shall discuss about the full subtractor design. This is the truth table of the full subtractor design, and this is the logic circuit of the full subtractor. The inputs are X, Y, borrow in. We have taken borrow in the place of carry in, and outputs as borrow out and difference in the place of carry out and sum. The difference will be 1 when only one or three input variables is equals to 1, and borrowed equals to 1 when the x variable is equals to 0, and there is an exception here and here. When all the inputs are 0, the outputs will be 0. When all the inputs are 1, the output will be equals to 1. And there is a slight changes in this logic circuit of the full subtractor is that here we have taken a NOT gate, and it functions in the same way as the full adder does. These two are the three variable came up for the borrow out and difference of the full subtractor design. This is the difference of the full subtractor, and this is the simplified equation of the difference output. This is a borrow out output. Now we shall discuss about the K-map briefly in the video. Let me explain the K-map for the full ladder. Now I have drawn the three variable K-map for the carry out and sum. From the truth table of the full ladder, we shall take the inputs 1 at 3 and 5, 7 and 6. These are the outputs taken from the carry out, which are here, and for the sum it is at 1, 2, 4, 7. Now we shall make the pairing. It is from here to here and here. Since there is no pairing for this, we shall pair it singly here and here. For carry out, we will get the output as C out is equal to, from here A is also not changing, B is also not changing, so A of B, and C in is changing, so we cannot take it, plus of, and here we will take A is changing, so we will not take it, B is not changing, so we will take B and carry in, plus of, from here A value is not changing, so we will take A, but B value is changing from 0 to 1, and C in is remaining same, so C of in, this is the output for carry out. And for some, S is equal to A bar, B bar, C in for this, and for here 0 means A bar, 1 means B, C in, plus of 1 means A, B, and carry in, plus of 1 means A, 0 means B bar, and C in bar, and here it is C in bar because it is here C in bar. So C in bar, we can simplify the sum equation as S is equal to A plus or B or of C in. This is the simplified expression. Now we shall discuss about the full subtractor design K-map. Now I have drawn the three variable K-map for the borrow out and difference. Now we shall take the value of 1 at 1, 2, 3 and 7, which are taken from here. These are the index values which are written here. And for the difference, we shall take it at 1, 2 and 4 and 7. The remaining places are filled with zeros. Now we shall do the pairing for this. Here to here, and we shall pair it here. These are singly paired since there is no possible of pairing. We shall get the output of the borrow. Now we shall write the output of the borrow out. B out is equal to, here x value is changing from 0 to 1 and y is remains same, so y of borrow in bar plus of, now from here borrow in is changing, so we will not take it, and x and y remains the same, so x of y plus of, here the value of x remains same, so x, y is changing, so we will not take it, and we will take borrow in bar. Now for the difference output, we will take it as d is equal to, here x is 0 means x dash of y, borrow in bar, this is for this, and plus of x is 1 and y is 0, so x of y bar, borrow in dash, plus of x is 0, y is 0, so x dash of y dash, borrow in, plus of x is 1, y is 1, so x y borrow in. This is the required expression of borrow out and d. We shall simplify d as d is equal to x plus of y or borrow in. This is the required expression. So thank you.